Okay, just looking at the general situation where you're given the equations of a couple of lines, horizontal and vertical lines. So we could have a line here and a line here. We want to estimate the point at which the lines intersect, and we want to estimate the equations of the lines. Now, I didn't state the problem as clearly as I wish I had, but when you see it on the test, and you're probably going to see it on the test, I'll state it more clearly. And the clarity is that we want to find where each line intersects a horizontal or vertical line, okay? So the way I would do it with these points, I'd use points as far apart as possible where I'm still intersecting horizontal and vertical lines on the graph. Now I could extend the y equals -5 line and intersect this with that line. That would be perfectly legitimate, and that might not even be a bad idea. But I'm going to stick to intersections with the lines here and here and here and here. Now, I estimate the coordinates of this point. Well, let's see, you got -1 and -5, so the distance between these lines is 4, right? And you go that much further down, and you'd be at y equals -9, wouldn't you? Okay, and then you got to go this much further down. That looks like almost halfway. So I'm just going to do a ballpark estimate. I could estimate this, the y coordinate, of course the x coordinate is -3. The y coordinate could be -9 or -10. Okay? I'm going to just use whole numbers. So I'm going to say, okay, -9. I don't know which one to use. It looks about half, 6 of one, half dozen of the other. This point here is going to be 7, what? Well, let's see, 4 units from here to here. That looks like about 4 units below the y equals -5 line. So I'm going to call that,
That's -9.
I should have been -10 or -11, and since I chose the lower, we'll call that -10. Okay? -11 might be better, because this line looks like it has a little more slope than that. We'll just take what we get. Okay. And remember, the x scale is a whole lot different than the y scale, right? So this is 10 units of x, and this is only 4 units of y. And that means that visually, you're not going to be able to really see what the slope is. Okay? Okay, well, this point here, we got -1, and that looks like it's between 1 and 2 again. So I know my estimates aren't going to be that great, but I want to illustrate that anyway. Not that I have any trouble making estimates that aren't that great, even when I try. Okay? But we're going to say that this is probably about -3. I'm going to say -3, 0. Okay? Because this is -1, we go up 1. Nah, I don't like 0. So say -3, 1. Okay. Now here, again, I've got 4 units from here to here. This is not 2 units and it's not 1 unit, right? But I want to use whole numbers just for illustration. If you were estimating this, you'd probably estimate this as about 1.5 units below -1, which would put it at like -2.5, right? But I'm just going to mess it up and say, okay, that's going to be x is 7. And y is, I'm going to say -3. Okay? Now the way those estimates work out, I kind of intentionally made it so that any estimate I make of this intersection point here is going to be kind of screwed up compared to the equations that I'm going to get for these lines. But okay, it looks like this point is a little below x equals -5, right? So I'm going to say, or I'm sorry, y equals -5. So I'm going to say that y is -6. Again, I'd want to estimate that a little more closely, but we'll go with that. And let's see, x is 3 and 7. That means it's 10 units from here to here. Now if I go over to here, 10 units, that's pretty close to 10 units, isn't it? So from x equals 7, I'm going to say it's about 9 units, and I'm going to say this is 16, negative 6. Okay? Now, when you're doing the problem, I want to see these labeled because I don't want to have to do my own estimates, simply because I'm doing a lot of stuff. And I want to have time to do as many of the things that I think we need to do as possible, so I don't have time to go and make my own estimates, okay? To figure out where you get the numbers that you use when you solve the problem, okay? So based on these numbers, I want to document where these numbers are. So I've labeled this point and this point and this point and this point, okay? I don't want to see a bunch of numbers over here that aren't related to these numbers, right? It's when you start calculating it. Then the other thing I really want to see on these problems is I want to see your fundamental triangles. Okay, so we've got a fundamental triangle here, and we've got a fundamental triangle here. Okay? And I want you to use these points, and the problem will be stated that way, okay? I want you to use these points and not this point and this point, and this point and this point to test whether your equations match your estimate of the intersection point. Now, they're not going to match perfectly, especially in this case, okay? And then, what I'd really like to see is, I'd like to see another fundamental triangle on each line that at least shows me that you understand that we could use the triangle from one of the points in XY, okay? And you can put the XY anywhere. You put it in the middle if you want to, but it's easier to draw the triangle if you put it to one side or the other of this triangle, okay? So I put this here, okay? Because I didn't want to put it here because I'm going to have a triangle from here to here as well. So just to keep it out of the way. And I'll do something similar over here. I'll have my point an XY on this line. Of course, that's going to be different than this XY, but I'll label it XY nevertheless. Okay? And these are the fundamental triangles that I would use to get the equations, right?
Yeah.
Okay? Then, it could be useful to have these two fundamental triangles in this case, okay? I wouldn't use these triangles to get the equation of either line, but we might get information from these triangles that gives us some indication of how good our estimates are. Well, then I just go ahead and label the triangles. Now, when I screw these up, you just keep me honest. This is going to be 10, and this is going to be 1. Okay? And this side is going to be 10, and this side is going to be always moving from left to right. This side will be negative. From 1 down to negative 3, this side will be negative 4. And then on this triangle, I've got what? I've got x minus negative 3 and y minus negative 10. It's different than this 10. Things are getting crowded there. Up here, I'm going to have what? Y minus 1 and x minus negative 3. That's almost all of my triangles, but of course I can do this one as well. It looks like I have a run of 9 on this one, and I'll have the same run on this one because they run between the same x coordinates. And I'm going to have a rise from 7 up to 16, from -9 up to -6, that's a rise of 3. And here I'm going from -3 down to -6, so that rise is -3. I've got all those triangles. Okay? At this point, I see a lot of what I want. Now, when you draw a picture of these things, draw it big enough, okay? And try to position things so you don't run into running things together like this that I can't read. Okay? So do better than I did. Anticipate things like that. Okay? Naturally, I anticipated. I put the 10 there just so I'd get crowded here. So I'd illustrate that you can get crowded, right? I saw that. Believe me. Okay. Well, don't believe me. Okay. And you probably should. Then I get my equations, right? So I get the equations. Now, if I say get the equations using the fundamental triangles, then you better set the slope of this triangle equal to the slope of this triangle. And I didn't label my slopes, did I?
No, you didn't.
Okay, well, my slope is going to be 1/10. My slope here, where I didn't leave myself enough room again, intentionally so I could illustrate, the slope is going to be, what, y plus 10 over x plus 3. And here the slope is going to be y minus 1 over x plus 3. Here the slope is going to be -4 over 10. Of course, that reduces, but. And here the slope is -3 over 9, which is -1/3. And here the slope is 3 over 9, which is plus 1/3, right? Make sense?
Yeah.
Okay, now that's really kind of screwed up.
Why? Because that slope's supposed to be perpendicular and not parallel?
No, they aren't perpendicular or parallel. None of these slopes are negative reciprocals of any of the others, so they're not perpendicular, right? And it turns out that none of the numerical slopes that I labeled are equal, although this should equal this.
So what happened? What would go wrong then?
Well, I did use estimates, right?
So that means the estimates.
My estimates were screwed up,
Yeah.
especially here. Okay? Although, 1/3 is pretty small, okay? So a 1/10 looks like it's a whole lot different than 1/3. Well, it is, but not that much. Okay? That can easily happen with your estimates, right? Okay, and -1/3 is pretty close to -4/10. It's like 0.33 against 0.4, right? This is like 0.33 against 0.1. If you subtract those, it's only 0.23. It's not a huge difference. And as I said when I was doing this, I intentionally didn't estimate these down to fractions, and I could have, and they might have been closer. Okay? Okay, so anyhow, we need to see all that before we
Get the equation.
do the rest of the work, right?